welcome to the Science Canvas. I'm John Paul Purification, your host for today, and I'm joined by Natalie Sullis, and we are here at the Solano Community College TV studio, and today we'll be talking about the cardiovascular system. So, Natalie, how are you feeling about discussing this topic?
It's a really interesting topic. How are you feeling, John?
I'm curious about it. I'm feeling fairly confident. I mean, we went over our content on how we're going to discuss things. So that which takes me to overviewing our segments. Our first segment will be, help give context, it's going to be background. So that will set the stage for the rest of our discussion. So, start.
There are 5 major blood vessels in the human body. Additionally, the heart has numerous of smaller blood vessels, including the coronary arteries and the veins.
These are the okay, go. So these are you can see from up here, these blood vessels, these carry blood around from the body. And so I think for context, what I would like to bring up is how the heart is a muscle. It's a muscle pump to pump blood. And if you ever used a bike pump, I have, yeah, it takes an air, valves keep it in, so you could force the air into the tire. It's a similar idea with the heart, except that you're pumping blood. So the blood vessels, they carry the blood on the pipes. And you can actually open it. The actual size of the heart is about the size of your fist, so like about here. But this is a little enlarged. You can see the detail. Here you could actually see the valves that are inside to help regulate the pumping. So, and the sound that is pretty familiar with is the beating, and what that is the sound of the heart. It's really just the valves opening and closing shut. And if you wanted to, and it does this pretty constantly. And what's your take on that?
A point to remember about the cardiovascular system is the heart has 4 chambers.
So chambers are here,
which are the right atrium, the left atrium, the left vertical,
and then 4 chambers. So these will fill up with blood, and then they pumps them. And so I mentioned the sound. And it does the amount of pumping it does, how much it does, it depends on your activity. So if you're resting, it's relatively slow, and if you're active, it'd be pumping faster. And pretty sure you have how many times does it beat, pump?
Oh. A fun fact about your heart you may or may not know is, according to the Healthline, Diana Wells, July 7th, 2017, your heart beats about 15,000 times each day. This means it adds up at an average rate of 80 beats per minute.
And so 80, as you heard, 80 is the average, and so that's where the sound of the heart comes from. And so
and here's what a heart sounds like.
Lub dub, lub dub, lub dub. It's the valves closing and open, slamming shut. So, and this is actually where it pumps from. It enters through this chamber and out to this artery to the rest of your body. So, the contraction of this muscle, it's regulated by the autonomic nervous system. So you don't control your heart directly. You kind of do, in a way, in that your activity determines, because you need oxygen to perform these activities. It's just how cells work. So the autonomic nervous system takes care of this, so it's involuntary. which brings me to our segment 2, which is how the cardiac muscle at the cellular level works. So Anthony Saxton et al. From the National Library of Medicine, August 8, 2023, references these cells as cardiomyocytes. These are individual cells that make up the cardiac tissue, which contract to pump blood. So instead of air, you have, from my pump analogy, it's the cardiac, blood cells. So at the cellular level, you have what's called these filaments, is another fun fact. These use what's called ATP energy, which comes from partly the food from pretty much the food that you eat. So it converts that energy into motion. So muscle cells are kind of fascinating how they use this energy to make motion. Like you can see from my hands, it's all motion. So at the cellular level, for the cardiomyocytes, these filaments slide as they use this energy. And you could just imagine more of these cells to form the heart tissue and ultimately the whole heart organ here. These contract in a ringing motion. So to be able to make that pumping possible. And as you mentioned, on average, 80 beats per minute. It's regulated by, as the heart, if you ever heard of a pacemaker to help those that, I guess, need it. A healthy heart has its own pacemaker to help regulate the heart rate. And it's also connected to the nervous system for that kind of purpose. And that's your take on that.
The cardiac muscle is called the mitochondrium. It's a thick layer in the middle of the heart. A point to remember about the cardiac level is what the function of the cardiac muscle is. It connects with okay, generating the force that pumps the blood out of the heart into the the system.
And I guess, how would you elaborate on that?
How would I elaborate that?
Yes.
An excellent example is provided by the article Vishal Raja in July 30th of 2023 in this physiology cardiac muscle. Cardiac muscle cells are strained and breech contains many mitochondria and are under the involuntary control.
I guess the fascinating part is, still at the cellular level, these cells are just really tiny, no?
Yes.
Really tiny.
Yeah.
Like even yourself is made up of cells. So, but to draw back our focus on the heart, at the cellular level, it takes in the energy. So ultimately, it's for pumping blood, and which will take us to our segment 3, which is how the gas exchange works. So, and a curious fun fact is how the red blood cells don't have a nuclei, unlike the rest of a lot of other cells. But so you have the blood at the level. So I'll go on to say that how Roland Lindsay from the Solano Press Encyclopedia of Health 2025, RBCs, that's short for red blood cells, they contain hemoglobin, which helps to carry oxygen to the cells and transport the carbon dioxide away from the cells. So, and these gases are exchanged in the lungs, which breathe in air and air out. It's not here, but they're connected to the heart. And yes.
Some more info on the gas exchange in the blood is when you inhale, the contraction of oxygen, CO2,
that's the fancy,
in the alveoli is higher than the blood arriving from the body. Because the pressure of the gradient, oxygen moves from the alveoli across the thin walls of the capillaries and into the red blood cells. We'll primarily about it in the hemoglobin.
So this alveoli is like kind of is spread all over your lungs. It's how the gas, the oxygen. So oxygen in the air there's more oxygen in the air than inside yourself, I guess. So the concentration is greater. That's why oxygen is going to move in the cell and the carbon dioxide out. So, and yeah.
Also, at the same time, the contraction of carbon dioxide, CO2, is higher in the blood returning from the body than in the alveoli in the air. Therefore, CO2 diffuses from the blood into the alveoli, where it's expelled from the body during exhalation.
And it's also, if you've ever seen artistic illustrations of, for the purpose of learning the arteries and veins, you'll notice that oxygen-rich blood cells tend to be colored red, and then the oxygen poor, because they've dropped off their oxygen and picked up carbon dioxide from like muscle cells and other cells in the body. They tend to be illustrated blue, but in reality, they're still red, but it helps to understand that there's a difference in as you mentioned, the oxygen, carbon dioxide concentrations are different. So, and then it's also worth adding that the rest of the blood volume is plasma, which is another topic of its own, where it's yellow liquid made of mostly water and other nutrients, but it's about half of it is actual red blood cells that carry oxygen and carbon dioxide for that gas exchange. So, and to close off, we overviewed the heart with some cardiology, how that is connected, and then our next segment was on how the cardiac muscle at cellular level works. We had the filament sliding, which is pretty fascinating. Just imagine that at a huge scale, you could actually have that pumping motion. And then we of course can't ignore how the purpose is to exchange the oxygen and the gas in the blood, which is the gas exchange. So that is closing, that would be it for Science Canvas. Again, I am John Paul Purification, here with Natalie Sillis, and we hope you enjoyed and learned a thing or two, some fascinating facts. We hope that this was an enlightening topic, and if not, I want to give credit in quote to have a heart. So thank you.
Thank you.
Thanks for watching.
If you are interested in a career in sports broadcasting,
whether you're commentating a live game
or hosting your own TV show,
for more information, contact Greg Poff. That's me at solano.edu.
We hope to see you here next semester. And remember,
it's more than just sports, it's an education.